Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at adding and subtracting algebraic fractions. So again, the same rules apply for algebraic fractions as for normal fractions. So even for normal fractions, you can only add or subtract them when the denominator is the same, and you only add or subtract the numerators, you never change the denominator. So for 3 over 8 plus 1 over 8, we just add the numerators, the top numbers. And we get 4 over 8, and I need to simplify that if possible. So 4 over 8 can be simplified to a half. For 2 over 5 plus 2 over 3, I can't actually just add the tops and add the bottoms. It doesn't work like that. I have to first make denominators, bottom numbers, equal. So what I need to do is times each of these by something so that they become the same. So I find the lowest common multiple of 5 and 3 is 15. So I need to times 5 by 3 to get to 15. I need to times 3 by 5 to get to 15. If I times 5 by 3 and 3 by 5, these two will have the same denominator. So what you do to the bottom of the fraction, you must also do to the top. What you do to the top, you must do to the bottom. So 2 over 5 becomes 6 over 15. They're equivalent fractions. Both 2 over 5 and 6 over 15 are equal to 0.4. 2 over 3, so 2 times 5 becomes 10. 3 times 5 becomes 15. So 2/3 and 10 over 15 are equivalent fractions. So now that they have the same denominator, I just add the tops. 10 plus 6 is 16, and I always leave the denominator unchanged. So the answer is 16 over 15. This is an improper fraction because numerator is higher. Nothing wrong with that. All right, let's look at some algebraic fractions. So x over 5 plus x over 4. So this is the same deal. I can't add them yet because denominators are not the same. So I'm going to times this by 4 and this by 5. Why is that? I'm going to make both of these denominators equal to 20. 20 is the lowest number that's divisible by 5 and also divisible by 4. So if I multiply the bottom by 4, I need to multiply top by 4. Multiply bottom by 5, I need to multiply the top by 5. So x over 5 is equivalent to 4x over 20. X over 4, that's the same as 5x over 20. So now that the denominators here are the same, I just add the numerators, 4x plus 5x. I leave the denominator, it never gets changed. That's my final answer. So how would I do something like 4 minus x on 3? Well, it's the same process, but I need to make 4 into a fraction whose denominator is 3, the same as that. So 4 times 3 is 12. See, 12 over 3 and 4 are exactly the same number. So I wrote it as 12 over 3 because now I have two fractions with equal denominators. So I just subtract the tops and leave the denominators the same. All right, how would I do this? This one's a little bit harder because of the x minus 3 there. So it is the same idea that we have to get denominators the same. So the lowest number divisible by 7 and 4 is 28. So I need to times that by 4 to get to 28, times by 7 to get to 28. So if I times the bottom by 4, then I need to do the same to the top. Whatever you do to the bottom, you must do to the top. So 2x times 4 is 8x, 7 times 4 is 28. So when I'm multiplying over here, I need to multiply 7 by the whole lot. Not just the x, not just the 3. I actually need to multiply it by both. So I'm going to get 7x minus 3 over 28. So now I combine these two fractions. I subtract the numerators, but I leave the denominators alone. So on top, I get 8x minus 7 times x. And this is negative 7 times negative 3, so it becomes a positive. All right, and of course, 8x subtract 7x is just x. So I'm left with x plus 21 over 28, and that is my final answer. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.